So yesterday we started working with the OOPS concepts. Yesterday we created a class called as point, which contains here two private data. One is xc and other is yc. Xc is x coordinate, yc is y coordinate. And here we have two constructors. One is point constructor, other one is point. Constructors are they take same name as a class name, but here overloaded. The first one is without parameters, second one is parameter as constructor. We pass two parameters, x coordinate and y coordinate to that. So this is what exactly, this is a construct, these are the two constructors we created, which take same name as the class name, but only the parameters change. In the first case, you have empty list of parameters. In the second case, we have two parameters, x coordinate as well as y coordinate. Then we have here methods like setX, setY, getX, getY to retrieve data from the private fields. The fields are private here, xc and yc are private. To retrieve data from them, we use setX as well as sety, getX and getY. With the help of that, we retrieve the data. Then we have written one more method called as move point. Using that, we can be moving the point. That means x coordinate, y coordinate we can change with the help of this method. Then other thing is here, we have a method called as get quadrant. In which quadrant the point is lying, we can find out. Since there are going to be only four quadrants, we can use four constants here. First constant, second, third and fourth, for which we have defined an enum. Enumeration we defined on the top. Enum, quadrant, first, second, third, fourth. So if you take quadrant, it can take four values, either first or second or third or fourth. We can restrict the values to only these four. Like this, we have created here an enum called as quadrant. We created a quadrant which can take values either first or second or third or fourth. This is called as user-defined scalar type. We can call this as user-defined scalar type. So using this quadrant, we can here return the value of I mean we can find in which quadrant exactly the point is lying. So like this, here we created a point class. Now it is more and more meaningful. You can find a quadrant from this. Similarly, we have overridden one method called a toString. ToString is defined in the base class object. So for every class, the base class is going to be object class. There are two methods in that. Get class name. Second thing is what here? ToString. These two you have within the object class. If you look at this here, I may create an object this way. Object. Just do like this. When I type here object dot, it can show you these methods. The equals method is available for us, which can be comparing for the two objects. We saw this with the string object some time back, if you recall. You can compare two strings, whether they refer the same location or not, you can find out. So when both the objects they refer the same one, the equals returns a true value, otherwise it returns a false value. Then with the help of get class, you can find out what is the class of the given object there. Similarly, toString. One more thing is going to be here, toString. So this is also very important. You can print the contents of the object with the help of the toString. So this method is available with the base class called as object class that we override we are going to override now in the point class. So in the point class we have written return. This is the public string toString. We are going to override this. What we have written, return values for coordinates x equal to xc, y equal to yc, and it's lying in quadrant. Like this we can print information. And when you click on when you move your position, mouse pointer over this arrow, up arrow, it shows there, it's overriding the toString method of the object class. So this concept is called as overriding. You are putting a new definition for this. Here we are defining new code for this. We are altering the existing code of the toString. So we are totally replacing, in fact, whatever was in that, we are replacing. So this feature is called as here overriding feature. We have overridden toString method. ToString is basically available with the class with the object class, but here what we do, we override it. We are overriding it. So when we override, it can give you different values for us. So this concept is called as overriding, and when it comes to this point here, it is overloading. Constructor has been overloaded here. Constructor is a special method which does not return any value, but constructor takes same name as a class name. Point is a class name. Here also point is a class name. In the first case, without any parameters we do. In the second case, we pass the parameters. Therefore, here it is giving you like this. Point without parameters, x equal to 0, y is equal to 0. And in the second case, we put point int x, int y, x is x, y is y. So like this, we have overridden the point constructor. This feature is called as overriding the class. We have overridden the class point without parameters. Second thing is point with the parameters. Like this, we have overridden the point class. Okay, we are overriding the point class here. Like this, it is written. Then when it comes to this is called as here overriding, and this is called as overloading. This feature we can call as overloading because it takes same name as a class name. And one more thing, it is having the method names are also same. So these are nothing but here constructors. A constructor takes same name as a class name. Then second thing, in the first case we don't have parameters. In the second case, it's having two parameters. Therefore, this is called as here overloading constructor. This is called as here overloading constructor. In the same way, we can overload the methods also. Methods also can be overloaded. And here what we do, we are overloading the constructor. But whereas the toString method is called as overriding. In the case of overriding, we don't alter the signature of the toString method. In the base class, how it is, in the same way we take it, but internally code we change. Within the method, whatever code is there, that we replace, we put new code, that is called as overriding. So like this, you have two features called as overriding and overloading. Overloading is compile time polymorphism, whereas overriding is runtime polymorphism. It can be behaving depending on the object there. So this is called as here compile time polymorphism. The overriding is actually runtime polymorphism. So when you execute, at that time it can be behaving in the polymorphic fashion. So like this, here we created a point class. It is containing here two constructors, then getters and setters we have, and apart from that, we write a method with the help of that in which quadrant the point is lying, we can find out. So this is what it's a point class we created. Now, next thing what we do here, we extend the point to point3d here. Point3d is a class. So using point3d class, here exactly what we do, we are extending, extra features we can put into point class here. Class point3d extends points. When we write, the features of point are added to point3d, and here extra dimension we added. It's nothing but third dimension, private int zc. It's called a z coordinate. We can call this as z coordinate. So this also has here 2 or 3 constructors we defined yesterday. One is point3d. So in the point3d we call superclass constructor. So automatically x and y are initialized. Then in the case of zc, it's going to be 0 coordinate. All the 3 coordinates, they are on the origin only. So z coordinate is 0, x coordinate is 0, even y also is going to be 0. Next, when it comes to point3d here, int x, int y and int z, like this you have. So here what we do, we write super xy, then followed by z equal to here z. So with the help of given xy, again we are calling the superclass constructor. We call like that superclass constructor with the help of the super followed by set of here parameters. Then after that we have written one more constructor, public point3d, point b int z. So here we invoke the superclass constructor again with a given point. Already you might have one point. With the help of that point, you can be creating one more point here. So therefore, when you take the point3d, what you can get here, super p.x get x, p.get y. Like this, you can find. So super p.get x, p.get y, we have written like this. So this way, we can be finding out here. We can find out here what exactly. Sorry, we can create a new constructor point3d. So with the help of getx, you can get the x coordinate. With the help of get y, you can get y coordinate of the given point object. Using them, we can create here a point object. Then after that, we initialize z. So totally we have here 3 different constructors for the point 3D. Okay. Now one more thing what I do in the point class, further I want to define another method. With the help of that method, I can find out the distance between some another point. From the current point to another point, what is the distance we need to find out. How it can be found out, just see here. Public, then followed by double this is, then what I pass in this public double. Here write find distance. Find length between points. Like this we can write so find length between points. We take like this, and here we may pass int x, other one is here int y. You can be passing these things. With the help of this, we can find out the distance. Here, from the current point it is. From the current point, how far it is away from the new point, we need to find out in this. So what is the formula we use to find out the distance between the 2 different points? I think use square root of x2 minus x1 squared plus y2 minus y1 squared. With the help of that, we can find out the distance between the 2 points. So here therefore write return. This way we write math dot strt, we can use square root. Math dot strt, we take this one, followed by here we need to pass the parameters. How parameters we can pass? We need to find out the distance between the x coordinate and y coordinate. So therefore here write like this, x2 minus x1 whole square we take, x minus xc, then we need to square it. So for squaring, we can use here math.toc, POW, sorry. We can use here POW. With the help of that, we can be finding out here POW we take here. Then here we need to square it, x minus xc, x2 minus x1 whole square, we take that. Similarly, we need to take here plus y2 minus y1 whole square, y2 minus y1 whole square we need to take in this. So that should be here again math dot POW, we take like this. The next one y minus yc we put, then after that we pass here 2. So this way we can be returning a value. This is basically what find length between 2 points. We kept like this here. Point distance between the 2 points we make this way here. So public double find length between 2 points. Here we specify int x, int y. So between the 2 given points we are trying to find out distance. Extra functionality we are adding to the point class now here. We are trying to find out extra functionality between the 2 points here. Okay. So next one, we overload this now. Find length between 2 points we are going to overload. So in such cases, do like this. So instead of using now this point x, this int x, int y, this time I can specify another point. Object P, I can specify here. object P, I can specify, then followed by here, I can write P dot, I can put like get X. Similarly, here I can write P dot get Y. I can use, with the help of that, I can be finding out the distance between the 2 points. Now this feature is called as here overloading the method. The method is what here? Find length between 2 points. We can be finding out the length between the 2 points this way here. So with the help of the first one, we pass here two coordinates x and y. So therefore, with the given x and y, from the current point, how much distant it is, we can find out. In the same way, with the next one, we try to find out distance between the 2 points. It is going to be current point dot find length between 2 points. We pass a point object to that. So therefore, with the help of that, you can find distance between the 2 points. You can be finding out distance between the 2 points. So this is called as here overloading the method. We have overloaded the normal method, find length between 2 points. The written type of that method is what here? Double. Then here we have written twice, but list of arguments are changing there. X, Y we have written, and other thing is what in the next case is point P. So these parameters are changing. Since the parameters are changing, this is called as here overloading. There is no change in the method name. Method name is intact as it is, but only parameters are changing. Therefore, this concept is called as here overloading the methods. Different functionality may achieve with that. The method name is same, but only list of parameters are changing. Like this, we can overload. So this concept is here compile time polymorphism. Before you compile, you need to finish it. So the code, whatever you write, is going to be getting compiled. Nothing is going to be getting bounded dynamically. So it is compile time. This is called as early binding or static binding. This you can call as static binding or early binding, whereas the overriding feature gives us a concept called as lazy binding or late binding. In the runtime, they can be bounded together. In the runtime, they will be getting bounded. So this way here, what is happening? We have written a new method. 2 times we are defining. There are 2 versions for this. One is what find length between 2 points. Int x, int y. Second one is we are passing the point object as parameter to the second method. So like this has been overloaded for us. This is called as method overloading. So twice we have defined the method. This is called as here overloading concept. Now let us try to use this in the main method. So we come to main method. In the main method, let us see this. We have here object 3D. Then we have here 2 different things. One is a point object, other one is object 3D. You are having 2 things. Object 3D is what here? It's a kind of basically point. So can we work with these? Let us try to see. Can we find the difference between the 2 points? Let us try to find out. We take object 3D as well as we take here simple point. What is the difference between these 2 points? Let us try to find out here. So here system dot out dot println. We try to find out here. Now object P, put like this. Dot when you type, it gives 2 different versions for us. Length, find length between 2 points. Point P we use here. So take this followed by, try to specify here which one that is point 3D. Let us try to specify. Object 3D we put here. This is going to give error for us. When you put this, definitely it gives error. Why it gives error? Okay, sorry. Let us try to run first of all. So should not correct. Let's try to run. So the value is going to be 0, 0, just it's coming. Okay, fine. Since object 3D is basically a Object tree is basically a kind of point class. This will not give any error. Suppose you put like this, int a equal to 10, put similarly double d you put. Okay, now d equal to, when you try to assign a, there will not be any error. You don't find any error in such cases. When you write like this, int a equal to 10, double d equal to a, when you write, you don't get error. So same concept applies in this. This is called as here upcasting the given object. It's automatically getting upcasted. The object is getting upcasted in such cases here. So it's going to upcast for us. Upcast meaning is here whatever 3D object is there, this you are upcasting to a point object. You can upcast to point object, because point class is superclass, whereas point 3D is what exactly subclass. So you are converting this into automatically a point class. Because of that, there is no error here. You don't find any error now in this. Okay, you take a point 3D, you can make it a point object. So you can refer with the help of the point object. But here you take a point object, and with the help of that you cannot be referring there object 3D. So in object 3D can be referred by, just a minute. Here to tell that object 3D can be converted to a point type of object easily, but a point object cannot be referring the object 3D there. So just try to do like this. I write another method in this. Okay. In this public followed by, here it is, double. I want to print here find vertical displacement. Find vertical displacement, or vertical distance, I'll say otherwise. Vertical displacement. To use here another point in this. This. Okay. The point we cannot use it. Correct. Try to double D. This is written fine. Yes, so here there are two terms we use. One is what? Upcasting, other one is downcasting. One word we use, it's called as upcasting. One more thing, we use the word as downcasting. There are two features we use. An upcasting, other one is downcasting. Whenever we pass here object 3D, this is automatically referring the point object. Okay, so using a base class reference variable, we can access a child class object. But using child class reference variable, we cannot access a base class. So using child class reference variable, you cannot access a base class object. But by using a base class object, we can refer a child class. Using a base class reference variable, we can access a child class object. So here, what is happening? This is exactly system.out.println object p.find length between points. Here I am referring point. So using point, you can access here object 3D, but using object 3D, you can't access a point object there. Reason, it does not allow narrowing conversion kind of thing. So automatically it can't be downcasted. You can't downcast. So what we do here, it is upcasting. That means with the base class, you can actually you can use it as a base class object. But if you take a reference variable of the base class, child class, with that you cannot be referring the super class. You take a subclass reference variable, with that if you try to use a base class object, so it is not possible there. Here you can put like this, object p equal to, put it as object 3D. There is no problem with this. When you put like this, there is no problem. But when you try to put here object 3D equal to here object p, it does not accept. It gives error for us. What it says here, see, type mismatch. Cannot convert from point to point 3D. You can't convert from point 3 point to point 3D. Because in the point you have only few features. When you take point 3D, it is having more features. So from where we can get those features in the point in such cases? Therefore, you cannot refer like that. Whenever you use object 3D, what happens? You have Z coordinate. But in the given point object, you don't have Z coordinate. So since there is no Z coordinate, automatically it can't be downcasted. But whenever you take here object P equal to object 3D, here what is happening? You have object 3D. So with this object 3D, you can be referring the point object. In the point object, what methods are available for us? Get x is available, get y is available. Similarly, find the distance between the 2 points is available. Then get the quadrant is available. So all those methods, they are part of the here the 3D class also. In the 3D point class also, since they are available, so you can cast it to point object. But when you take here a three-dimensional, a object of the point 3D, if you try to refer a point class, it cannot. Reason, when you look at the object 3D, it contains some other methods like getZ method. Similarly, getZ, setZ you have, and apart from that, one more thing what we have in that, we have overloaded toString. If you come to this, we have overloaded, I think, the toString here. So in the case of toString, we are even printing Z coordinate. So when you try to call the toString method, from where it can print Z, therefore here downcasting is not supported. This feature is called as downcasting, and this one is called as typecasting. So in such cases, forcefully you must do it. Like this point, then followed by try to do it. In such cases, it can be accepting. Still, it does not support. So it can't convert from point to point 3D because the object 3D is containing here the methods like getZ, and other thing is for toString. In the toString method, you have Z coordinate. But when you look at point object, it is not available. Therefore, it's not going to be accepting the downcasting feature. Upcasting you can do, but downcasting is not possible in such cases. So like this, if you try to write, it gives error. Like this, it can't be done. But what you must do in that case, you must put here point 3D. Like this, if you put, that should be working. But here it does not work. Okay, what is the class name we have? Point 3D. Okay, the class name is here, capital D, we need to put here. So like this, forcefully you should be converting it. Object 3D equal to point 3D, objp. So forcefully like this you must be doing. Automatically it will not be done. So this feature is called as here downcasting. There are two features, one is upcasting, other one is downcasting. So this you find with the object-oriented programming languages. So here we have overloaded. We overloaded method. The method is what exactly? Find the distance between 2 points here. Find length between 2 points. Distance or length it is. So in the first case we passed x and y coordinates. In the second case we are passing only just point object. Using that we try to find distance between the 2 points here. So between the given points xy coordinate and with the new xy coordinates, what is the distance between them? You can find out. Similarly, you can find the distance between here, the given point and the new point. Like that also you can be finding the distance there. Okay. Can you find the angle between them? Is it possible to find the angle between them when you know the 2 points? Is it possible to find the angle? Normally, how do you find angle between the 2 points? So what is the slope? How to get the slope? Normally, what is the formula for slope? I think that is x2 y2 minus y1 by x2 minus x1. With the help of that, probably you get the slope. Is it correct? Because long back I did with mathematics. So I think using y2 minus y1 divided by x2 minus x1, you can be finding out the slope. So therefore, you can find the angle between the 2 given points also. Therefore, try to put here public, then this is here, double we can write, but angle we should get here. So in the case of angle, here, first of all, math dot, we have here, nothing we can do here, because within the class simply it can't be written. Somewhere inside this, we should do it. If you put here math dot, then it's available for us. So into radians, we need to find out first of all. So 2 degrees, we can convert it. Double argument. So probably into degrees, we can be finding it. Math dot 2 degrees, with the help of that, we can find out it. Let us try to find out what do we get see in this. So right here, public, then here we use double. This can be an angle. We try to find out. Find slope between the points. Try to specify here the angle. Not angle, the other point we need to specify here. Either we can give int x, int y, or we can specify here again point object. So like this we are going to write like this. Here in this we'll return, write like this here, return, what we are going to return in this, we need to find out slope between points. Okay, return this is here math dot 2 degrees I think first of all we should convert into 2 degrees. Then here try to specify the value between x2 minus x1 and y2 minus y1. X minus, we put it as xc divided by y minus yc. Like this we take, try to convert into degrees. What degrees we get, let us see in this. So let us try to specify some point in this, then see here. Then system dot out dot println. So here we try to specify the angle. X must not be changing, only y has to be changing there. X should be same, only y has to change here in this. So when it's minus 20, let us try to put it as, how much we put there, 0 we put. In such cases, it should give a 45-degree angle for us. Println, then followed by, we specify here point, this is object P dot find slope between 2 points, then we specify x and y coordinate. X is going to be same here, it is nothing but 10, but will not it give a error, because y2 minus y1 by x2 minus x1 we are doing. So this can be probably giving error for us, because x2 minus x1 is going to be 0 for us there. So there is no change in the x coordinate, but you have a change in the y coordinate. Even x also must change in such cases. Let us try to give something like here 20 and 0. Let us put what it prints. Let us see here in this. Showing here 0, because 0 0 is that much only. So try to put some 10 here. Still it shows 10. What is the reason? y2 minus y1. 10 minus 20 is minus 10 divided by x2 minus x1. So 20 minus 10 is going to be 10. It should be minus 1. We have minus 1. So when you have minus 1, what should happen in such cases? X minus xc divided by y minus yc, wrong. Okay. Yes. Y minus yc we take, followed by x minus xc, then even multiply this with the 1.0. Like this we take. So we just try to see now this result. It's giving 171.887385392467. Will it give that much angle when we pass these parameters? How it is? How much we give here the values? We give 20 and 10. The first one is what here? 10 comma minus 20. This should be, how this is giving, it should not be, because x is always positive only. From fourth to, they are coming into first quadrant. So in such cases, definitely the angle must be, is it equal to 180? Do we get this much? 171, is it correct value? Can we get that value there? Is it possible to get that value? 20, then other thing is 10 we have there, 20 we have there. So minus 20 and plus 10, this is okay. From fourth to first quadrant we are jumping there. So in such cases, do we get that many degrees? It's crossing 90 degrees even. It's crossing 90 degrees. 171 angle it's giving. Okay, so some extra effort we have to put in this to do exactly how to convert. But these are available for us automatically, so already ready-made are available, just we can use them. But here we are trying to find out something on our own. So when you do graphics programming at the time, all these are going to be very, very useful. In fact, the engineers, people who have qualification in BTech, they are very good with physics and mathematics. They are recruited for not general kind of applications. For making web application, their skills are not needed. for developing database applications, their skills are not needed. When you do something related to system programming, there the service of engineers required very much. Graphics applications, when you build at the time, it's required. When you want to build applications like AutoCAD, STAAD application, Adobe Photoshop, so similarly 3D Max, in such cases you need to build graphics related libraries. So at that time your skills are very much required, your knowledge is required. But normal applications like JSP or similarly just to work with the databases, our skills are not required in such areas. Anyone can do that. Okay, so when you want to work with graphics based gaming, in the gaming your skills are very much required. So in the case of security, it's required. In the case of cryptography, your skills are required. But for normal web applications, database applications, anyone can do it. So serious career you have actually when you work with such things, the C++, even with Java you can do, but you should be doing more and more related to graphics. Graphics is evergreen when compared with other disciplines. These are simple applications, but features are going to be features are going to be same. But normally Java is made for simple applications. Industry strength applications you can make, but mostly they are oriented for business that they use. So here we have overloaded the two methods. That's what find length between 2 points we could find there. But slope somehow we are not getting correctly. This is correct or not, we need to check. I plot today on some graph paper and I try to see whether that is correct or not. I can find out. With the protractor I can measure actually that one and I see this formula is working correct or not for us, we can find out. But in general, use this formula with the help of that, you can get it. Because y coordinate is coming in the, fourth quadrant, x coordinate, y is in the negative, so second point is in the, first point is in the fourth quadrant and the second point is in the first quadrant. So 180 approximately, it's coming to 180, possibility is there, it may have 180. But that much we get or not, we need to check. With protractor only when we measure, we can find out that particular thing. Okay, so this is related to point. We do tomorrow further because many they miss actually. We'll be doing with the abstract classes. Then similarly, we'll be further extending the abstract classes, abstract methods and final classes. We do tomorrow those. I think some of you have exams, you are busy with some final exams I think, with that everyone may not be attending. So tomorrow we continue further.